Today we're going to be going through lesson 24-2, more circles. First we need to review the vocab. We've got a circle, which is an infinite many points that are equidistant from a center point, which is over here. Center point is just the middle of the circle, which is equidistant from all the outer points. Then we've got a radius. A radius goes from that center point to the outer edge of the circle. A diameter goes through the center point from one edge to the other. A chord goes from one edge to the other of a circle anywhere. It can be a diameter, but it doesn't always have to be. We've got an arc, which is just a portion of a circle. A tangent line, oops, that was a pretty bad one. A tangent line intersects with the circle only once. And it's also perpendicular to the radius / diameter. A non-tangent line is any other line. And then the point of tangency is where that tangent intersects with the circle. And then we have equidistant, which I referred to with the center point and the circle. Equidistant is just equal distance. That's all it means. And then concentric circles are circles that share the same center point. So there can be infinite many circles that share the same center point. Then today we learned 3 different rules. The first rule states that when a diameter is perpendicular to a chord, that diameter bisects that chord. Bisects just means cut in half. Ooh. And perpendicular makes a 90-degree angle. Okay, so we can make the diameter, so it goes through a center point. And that's saying if this diameter is perpendicular to a chord, then we know that it bisects said chord. And the reverse is also true. The converse is also true. We have another circle and another diameter. If the chord is bisected, then we know that they are perpendicular. So here's an example of what we would be seeing. We've got a diameter. It is perpendicular to this chord, so therefore we know that this chord is bisected. So if this side is 12, then we know that x also equals 12. And that's our first rule. Rule number 2, zoom in a little bit. In a circle, 2 congruent chords are equidistant from the center. So if we were to draw 2 chords that are congruent, these 2 are congruent, I know that they are the same distance away from this center point. So this segment would equal that segment. Okay, they are equidistant. So in this example over here, if PQ is congruent to RS, if these are congruent, what is the relationship between AO and BO? Well, that is the distance the chords are away from the center point. So therefore we know that AO is congruent to segment BO. That's the second rule. And then this third rule. When 2 chords intersect, the product of those new segments are equal. By product, what do we mean? We're meaning multiplication. Okay, so I've got a chord here and another chord there. It's Christmas. We're going to call this A and B. And then we'll call this C and D. I know that A times B is equal to C times D. Okay, you're using the segments from the same original segment to multiply together, and then they are equal to each other. So in this example over here, we'd have 8 times 7 is equal to 14 times x. 8 times 7 is 56, 14x. Divide by 14, and we know that 4 equals x. Okay, so those are our 3 rules, and now we're just going to go to the back and practice using them. So this first problem, a chord of a circular clock is 12 inches long, and its midpoint is 8 inches from the center of the circle. A, what theorem can you use to determine the length of the radius of the circle? So first, I want to draw my image, get a little bit of an understanding of what's going on. So I've got a clock. There's a random chord. Doesn't really matter where you put it. This chord is 12 inches long. Okay? And then the midpoint of said chord is 8 inches from the center of the circle. 8 inches. So if this is the midpoint, I know that that is equal to that. It's congruent to that. So now I am searching for the radius of this circle. And since I bisected this chord, and this is coming from the center of the circle, I automatically know from, what is that, rule number 1, that this is a right angle. So, right here. So what type of triangle did I just make? Oh, a right triangle, which means that we can use the Pythagorean theorem to find the radius. A squared plus B squared equals C squared. So my radius is going to be x. And then if you look at this, it says that this whole chord is 12. Well, we only need half of it right now. And so we just do 12 divided by 2, which is 6. And now I've got my right triangle. So 6, 8, and x. So I've got 6 squared plus 8 squared equals x squared. 36 plus 64 equals x. Oops, that's supposed to be squared. 100 equals x squared. Square root 10 equals x. That is my radius. Alright, next problem. A chord of a circle is 15 inches long, and its midpoint is 9 inches from the center of the circle. Again, I'm going to first draw. A chord is 15 inches long. The whole thing is 15. And the midpoint is 9 inches from the center of the circle. Calculate the length of the diameter. So just like our last problem, we've now got a right triangle right here, and we can find the radius. Start as x. So first we do 15 divided by 2, which is 7.5, so we can have this little triangle right there and be able to use Pythagorean theorem to solve for the radius. So 7.5 squared plus 9 squared equals c squared. 7.5 squared is 56.25. 9 squared is 81. Add those together and we get 137.25 equals c squared. Square root, this is the radius. That is what equals x is equal to. Which is approximately 11.2-ish, but I'm going to leave it as a radical. Because I don't actually need the radius, I need the diameter. So how many radii does it take to make one diameter? 2. So all you have to do is 2 times the square root of 137.25. So the diameter equals 2 square root 137.25, which is approximately 23.4. But we'll just leave it as a radical. Alright, next one. Given EF is congruent to AB, explain how you know that EF and AB are not equidistant from the center. Well, if we go back to our rule, I believe that was rule number 2. In a circle, 2 congruent chords are equidistant from the center. How many circles? 1. In a circle. How many circles are in this problem? 2. They're on different circles. They are concentric circles, which is cool, but that doesn't make them equidistant from R. So they're on 2 different circles. Oops. Therefore, not equidistant. Gotta be careful. Next one. In the circle shown, what is the measure of x? Show your work. Well, I've got 2 chords. They intersect each other. So rule 3 says when 2 chords intersect, the product of the segments are equal. So all we have to do, move up a little bit, back down, is x times x equals 49 times 4. X times x equals 49 times 4. X times x is x squared. 49 times 4 is 196. Get rid of the squared by square rooting. X equals 14. Boom. Easy. Last one. In the diagram shown, explain a method for determining the values of x and y, then find x and y. Well, if you were to just get rid of this little line right here, cover that up, what problem does this look like? Oh, it's just 2 chords intersecting with each other. So we know we can use rule 3 again. And we'll just do 20 times y equals 16 times 16. To solve for y, 20 times y equals 16 times 16. 20 times y is just 20y. 16 times 16 is 256. Divide by 20, and y equals 12.8. Now that we have y, we can uncover this x again. Get rid of this. And this little piece right here, make it in green, is 12.8. Now, if you'll notice, we've got, what shape is this? A right triangle, so we can use Pythagorean theorem. A squared plus b squared equals c squared. We are solving for x, which is the hypotenuse. So we've got 16 squared plus 12.8 squared equals x squared. 16 squared is 256. 12.8 squared is 163.84. Add those together, you get 419.84 equals x squared. Square root, which is approximately 20.5. But we're just going to leave it as our radical, and x is equal to the square root of 419.84. And that's what we've learned today. So your homework after this, which is actually what we did in class, is lesson 24-2. The end.